Hello. In this video, we're going to be graphing absolute value inequalities. If you have not watched absolute value functions yet, I highly suggest that you do so before watching this video. In absolute value functions, we establish the parent function of an absolute value. We establish that it's going to be a v with the vertex located at the origin. So we also reviewed our translations. If you have not written down these translations where you can reference them fairly easy, I highly suggest that you do that. Like, pause the video right now and write it down. Okay, so adding something new, absolute value inequalities. We are going to still use translations by to determine the vertex. Then we're going to graph the line. If it is a greater than or less than sign, it's going to be dotted, and if it's greater than or equal to or less than or equal to, it's going to be a solid line. Just like when we graph linear inequalities. Also, just like when we graph linear inequalities, we have to shade, and if it's a less than sign or less than or equal to sign, we're going to shade below, and if it's greater than or equal to sign, we're going to shade above. So already in absolute value functions video, we graphed this function here. Well, I think we went up 4, but that's okay. This one's extremely similar. So, but here, what if we want to say, instead of equals f of x equals, now what if we say f of x is greater than or equal to? So because it's greater than, we know it's going to be shade above. Equal to, we kept the line solid. So because it was greater than or equal to, we didn't have to change the line to a dotted line. We kept it solid. And because it was greater than, we shaded above. So here was another one from linear functions video. Plus 1 moved us left, and minus 2 moved us down. And so we graphed this function right here. Now, what if we said that this was f of x is less than 2 times the absolute value of x plus 1 minus 2? Now, because this is less than, we know that we need a dotted line. We also know that we need to shade below. So we're going to shade everything below that function. So we're still graphing just like we did in absolute value functions. We're still shifting left or right, and we're adjusting our slope as necessary. But then we need to account for what type of line we have and where we're shading. So this one, I want you to try it yourself. I want you to graph it, account for the line, and account for the shade. In 30 seconds, even if you don't actually get it sketched out, at least know if it's going to be dotted or solid, shade above or below, and if you're shifting left, right, up, or down, or a combination of those translations. Begin now. Okay, let's review this problem. So first we have a minus 5 on the inside, meaning we are moving right 5. We have plus 4 on the outside, so we are moving up 4. Now we know that the slope is a negative 2, so I went ahead and instead of putting a parent function where the slope is 1, because of technology, it was just easier just to go ahead and to make this green line have a slope of 2. So we need to move it right 5 and up 4. We also know because it was a negative 2 that we need to flip down. So we're going to take away that top part. We flipped it down because it was a negative. Now, with our inequality sign, this is greater than. It's not equal to, so we know we need a dotted line. And because it's greater than, we also know that we need to shade above, which is what we've done here. So hopefully between this video and the last video, you are very confident graphing absolute value functions. And then after this video, you just know how to add back in those inequality features that we'd already learned about graphing linear inequalities. This concludes our Unit 1, functions and linear functions and all that fun stuff. So our next unit, we're going to begin systems of equations. I will see you then.